Hello everyone and welcome back to the Python OP series. This is the final video on this series. In the previous video, we learned about MyPy and how static type checking helps catch bugs before our code ever runs. We saw that type hints are more than just documentation. When combined with tools like MyPy, they become a powerful safety net for large Python projects. Today, we're taking one final step in our typing journey. We're going to learn about advanced type hints. These are typing features you will encounter in professional Python codebases, FastAPI applications, backend services, and large production systems. Today, we'll be covering typing collections, optional types, union types, type aliases, TypedDict, Callable, TypeVar, etc. By the end of this lesson, you'll understand the most important advanced typing tools used in modern Python development. So let's get started. Now, before we dive into advanced typing, let's do a quick recap of the previous video. We learned that type hints improve readability. They make code self-documenting and easier to understand. We also learned that MyPy can verify those type hints and catch mistakes before runtime. We also learned how to install MyPy using UV and pip. Today, we're building on that foundation and learning how to describe more complex data structures and functional relationships. Now, let's switch to code. Now, let's implement a list. So, as I said, one of the first limitations of basic type hints is containers. So, for our name list, we'll have three names: Alice, Bob, and say for C, Charlie. This tells us it's a list, but what kind of values are inside, or what kind of values are expected inside the list? It can be strings, integers, objects. Python does not know that. Now let's improve this. So what we can do is we can give square brackets here. We can give square brackets here, and str can be used. All right. Now we're being specific. This is a list containing strings. Let's look at a few more examples. Here, the scores dictionary expects string as key and integer as value. Here, user IDs, which is a set, expects only integers. And here, record is a tuple, which expects string and integer. These annotations tell both developers and tools exactly what each container should contain. This becomes extremely useful in larger applications where data structures are passed between many modules. Now, sometimes a value may not always exist. Let's imagine a user profile. Let me remove all this. Let me implement a get email function which shall either return string or a none type. All right. Now let's return none. This annotation tells us this function may return a string or a none. Now, in older Python versions, instead of this, let me comment this out. What was used was we used to import optional from typing. From typing import optional. And what we used to do is we used to say, let's implement the same function again, get email. The pattern is almost exactly the same till here. Then we used to use the optional keyword and pass str or string, and then again we type return none or any other logic here. Both mean the same thing. However, this is used in today's systems more often, but you'll still come across these while reading older code. So let me comment this out and let me uncomment this one. All right, now let's look at union types. Suppose an API accepts either an integer ID or a string ID. Say we're implementing a function called process user, which is a common function that is implemented in backend functions or backend applications. User ID can be either an integer or a string. Now, say process user returns an integer. Now we shall return int user underscore ID. All right. Now the function clearly communicates that multiple types, say integer and string, are acceptable. This is common in APIs, configuration systems, and data processing applications. Sometimes type definitions become long and difficult to read. Consider, now first let me remove all this. Now let's implement another getUser function. And what we can do here is pass user ID, which is an int, and this shall return a dictionary of string, and either string or integer or say none. Alright, now this is our function, and let's just pass. The return type here is technically correct. However, the problem is it's not very readable. Let's try and improve this. Instead of doing all this, what we can do is, let me not remove all the function. What we can do is we can create a dictionary called user ID. First, user ID is supposed to be an integer, then user profile, for example, which is to be returned, is a dictionary with the values required. For example, str, str, or int, or none. Alright, now instead of writing all this, what we can do is we can write user ID, and here we can put user ID and return user profile. This makes our code much easier to understand. Experienced engineers often use aliases to make complex types self-explanatory. One of the most useful typing features is TypedDict. Imagine we're working with API payloads. Without TypedDict, we might write something like this. Let me remove all this. Now we're entering TypedDict, so let me put TypedDict here. User and dictionary, and what we'll do is we'll open our dictionary with curly braces, and ID, say ID is 42, and username, say username is dev user, and an email. See, email at the moment is none. There should be a comma here. All right. The problem is that the type checker does not know which keys should exist. Now let's make it explicit. Now from the same library where we imported optional, let's import something called TypedDict. And let's make a class called user payload, and we will be using TypedDict as its parent class. Now what we'll do here is we'll define everything. So int, similarly username is supposed to be str, and our final email, which can be either a string or none. Now let's create an object. Say user and user payload. We open curly braces, and what we can simply do is pass ID and 42, just like we did in the last one, and user name. So username can be the same div user. There should be these here, comma again, and email shall be none. TypedDict gives structure to dictionaries. This is extremely useful for API requests, API responses, configuration files, and database records. MyPy can now detect missing keys, incorrect types, and invalid structures automatically. Now let's briefly look at two advanced typing tools. Let me remove all this. Now the first tool we'll be looking at is called Callable. Callable describes functions as values. So again, from typing, what we will be doing is importing Callable, and let's apply an apply function func and callable and open our braces, say a list of integers and a string. All right, now value is int. Now from this function, what we'll be returning is a string, and what we will be returning is func value. This tells us the function parameter must accept an integer and return a string. Now let's look at TypeVar, which is another one of these. So let me remove all of this and import TypeVar. Now t is equals to, let me type t is equals to TypeVar and say t. Now let's create a generic function. See, our function is called first, and what we will be sending is items list t, and this shall return t as well. Now what we will be doing is we will be returning items, say 0. Now let's test this. Now let's print first of say, let me open parentheses, say a comma b comma c. Now let's run this code. Let me open my terminal, new terminal, and as usual, for the last time in this series, let's type python main.py. We get a TypeVar allows us to write reusable functions that remain type safe. So we are type safing the function regardless of the input type. This is the foundation of generic programming in Python. Now, where do these advanced type hints actually appear? The answer is everywhere. FastAPI uses type hints to generate API documentation automatically. Pydantic modules use type annotations to validate and serialize data. Teams working in large backend systems rely on advanced typing to improve maintainability and reduce bugs. As projects grow, advanced type hints help developers understand code faster and refactor with confidence. Typing has evolved from an optional feature to a standard practice in modern Python development. Now, this video marks the end of our Python OOP series. Let's look at how far we've come. We started with classes, objects, encapsulation. Then we moved into inheritance, polymorphism, and abstract-based classes. Then we explored tundra methods, operator overloading, and the very important decorators. And finally, we explored generators, context managers, type hints, myby, and for the final video, advanced typing. Together, these topics form the foundation of professional Python development. Whether you're building backend systems, AI applications, automation tools, or web services, you will encounter these concepts regularly. Now, let's finish with a few key takeaways. Annotate your functions, annotate your classes, use meaningful types whenever possible, run mypy regularly, and gradually adopt more advanced typing features as your projects grow. Type hints improve readability, mypy improves safety. Together, they help create cleaner and more maintainable software. Now, thank you for following this Python OOP series from beginning to the end. I don't imagine many of you are here. In the next series, we'll begin exploring PyTorch and modern machine learning development using many of the Python concepts you've learned throughout these lessons. I'll also be uploading system design videos or just in general Python and production grade backend system videos as we go. If you found this series helpful, please make sure to like the video, subscribe to the channel, and leave a comment. Tell me which topic was your favorite or what topic you'd like me to cover next. Thanks for watching, and I'll see you in the next one.